Hello students and YouTube learners. This is Dr. Satish Singhal, PhD, Professor of Computer Science at El Camino College, Torrance, California. I'm here in the next video, searching and sorting, video number 2. In video number 1, we showed you how to search an array of same data type, atomic data type, although we use string, which is not an atomic data type. And this time we show you linear search on an array of structures. So searching an array of structure, the array of structure may be searched for the key, for single key, that is just a value of a field in one of the struct instance in the array, or one can search the structure array so that one of the array member has all fields equal to the struct key being searched. Okay? But generally, however, array of structure is searched for one field or data member, which could be different for each array member, but then we want to print all the fields of that array member where that particular key is found, and we'll show you an example of that. So, or maybe in the short I can tell you right now, let's say I'm looking for ID of a student and I found that, and then I want to print all other fields of the student as well, like first name and last name, ID just I found, GPA and age, and we'll show you an example of that in our linear search algorithm for struct array. So if I want to search for many fields, not just an ID, then I can pass linear search function a boolean flag. I'm sorry, it's not going to be a boolean flag, an int flag, and the flag value can determine the search basis being used in the array of struct. Okay, so imagine a struct student with the array str like this one. So here's my struct student. It has field first name, last name, ID, age, and GPA. And in the main function, then we make this declaration: student str, which is my array of length 5. So what's going to happen is that computer will create a structure like this in the RAM, and what happens is that with the string variables, a zero length string is automatically created in all the array members. So there will be zero length string stored for first name in str 0 and 1 and 2 and 3 and 4 and same thing with the last. But others will be like undefined because we have not put anything in them. So only string is initialized with zero length string. Okay, and this would be first name field in each array member. This will be last name field for all array members. This will be ID field for all the array members being str 0, 1, 2, 3, and 4. This will be age field. This will be GPA field. These question marks and zero length string will disappear when we actually put a value in them. Okay, so how do we put a value? So one technique to initialize struct member to value that we want is like this. I can say str0 equal to curly brace, value of the first name field, this one, value of the last name field, value of the ID field, value of the age, and value of the GPA. So understand that to do initialization like this, the values you put here have to be exactly in the same order in which struct members are defined from top to bottom. You cannot move them around. And in a way, it's very similar to array. Remember when you declared an array, you had first value, comma, second value, comma, third value, and they took residence in the array like 0, 1, 2, 3. So it's actually very similar. So like John would be first name. So think of this, that in this initialization you took this and you just kind of pushed that right here in this str0, which was here. So John will be the first name field, Jackson will be the last name field, ID will be 999, which is here, age will be 35, which is here, and GPS 3.9. So learn this technique also of hard coding structure initialization. Okay. Now I want to populate all the array members before I can start searching them, and we can do it this way. So let's get these in the view. So str00 John Jackson 999 3539, so it gets filled as if I took it this and put it here. Tim Adams 1234, age 23, GPA 2.9 goes right here in that order. Tim here, Adams here, 1234 here, 23 here, 2.9 here. In the same order, this is the first name, this is the last name, this is the ID, this is the age, and this is the GPA. And then I do the same thing for Bertha Bentley, fill from top to bottom, first, second, third, fourth, fifth, first, second, third, fourth, fifth. And Cindy Gomez, same thing, and Lisa Nguyen, same thing. So this initializations will fill my str array like this. Length 5 means I'll have 0 to 4 indexes, and they're filled like that. It's very important you remember this, because we're going to come back to this when we do search and refer it back to it. So let's say, or maybe we can do this right now. Let's say I want to search ID of 2, 2, or let's say 4, 4, 4, 4. So I'm going to search through this. I'll try to match with this one, but that's not 4, 4, 4, 4. Neither here, neither here. Once I find this, I know I found this ID, and I can print the record of Cindy Gomez, this ID, age 30 and 3.7 GPA. Okay, so this picture is very important to keep in your mind. You need to build a mental map of this declaration, this array declaration, these initialization, and how it looks in the RAM. If you don't make a mental map of this, in fact, this document will be available to you also. You can look at it as long as you like. But this is the key thing to understand when you search an array of structure like this one. Okay, and we'll come back to this again. Okay, so notice that str can now be searched based on ID containing one of these records, or last name or first name. I can search based on the first name or the last name. So array of structure can be searched based on multiple criteria. We could write several functions, one for each criteria, but that's like too much coding. There are easier ways to do that. So typically how our search is done based on a field, where field acts as unique identifier. I mean, there could be many Johns in the array of structure. Many students may have the same name as John, and many might have the same GPA, many might have the same age. But one thing that would be different for most, that ID will be different. Such a field is called unique identifier, and in database technology, such field is called a primary key. Okay? Imagine that we wish to search array str based on field, either of these, ID, first, last, age, or GPA. How would our search algorithm change in that case? Well, actually it doesn't change that much. We would just compare the search field from the key, the same field in each array member, and this new slightly altered algorithm is shown right here. So earlier I was iterating through the array. I still do that. I set a found to false, and while index start index 0, index less than n, and not found means I'm negating this. Since this was false, negating this will become true, and index equal to index plus plus or index plus 1. But this time, since it's not an atomic array, it's an array of structure, I take my key and I take the member in that key. Key is the struct now, it's not atomic data. I take the member stored in that key and compare that with the array member dot the struct member in that. So let's clarify that. Let's say I'm looking for a struct which has the key of 444444. Well, I'm just going to look only at this. So this will be ASTARR0 dot ID. Okay, and I'm going to look for the key dot ID and match with that, but there's no match. And then I'm going to take key dot ID, which is actually 4444, and try to match with this STAR1 dot ID, and there's no match. And same thing here, no match. And finally, I'll find the match here. Okay, so that's how this algorithm works, and it will become more clear when I discuss the code. Okay, so that's the algorithm. Notice that just one line of code had to change. Only line of code that changed is this one right here. But if I want to search based on ID, first name, last name, age, or GPA, then we want to pass a flag, integer flag, to the search function, which will define as to which basis we do our search. So our new prototype for the linear search function for this struct array will look something like this. This part doesn't change. This part doesn't change, except we are passing the array of struct now. This part doesn't change, except our key is now a struct, not an atomic data. This flag will define as to what basis we're going to do the search. Like, for example, we can say if flag is 1, search only the ID row in this structure. If flag is 2, search only the last name, and so on. Okay, we'll see that in the code. All right. And then in this case, we want to do one more thing. It's not enough that we just found that ID. We also want to print all the details of the structure, like first name, last name, age, and GPA. So we do need to return the index where we found it, if we found it. So by reference, we return found at is the index where struct is located in the struct array. And of course, we have to pass the logical length, field length of the struct array. Okay. So there are two extra parameters in this function compared to the linear search for atomic data type. One is this flag and other is the found at. All right, and the purpose is this will define the basis on which we'll do search. This will, if found, it will return the index of the location where our key is located, struck with our key is located. Otherwise, we'll return a -1, which is impossible index for an array. Okay. There's no value set for it in the main function. This value is set only by this function actually. Okay, so now we're going to show our entire code in the Xcode, and there we'll go through a lot more detail. I may have to come back to this. I'll leave this page open and let's go to the Xcode now. Okay, this is Xcode. So let me show you a few things first. One thing is that I do exact same thing, max is 5, that I showed you in the Word document earlier. And when I do this, I would have created in my computer a structure like this one. All right, exactly like this. And when we search, we'll search this one for this one, sequentially from STAR00 to 1, 2, 3, and 4. Okay. Okay. Ignore all the commented out code. And then I do have a couple of other functions that I use. A print function that prints only a single struct, and I don't believe I use the array, so I'm not going to talk about this, but I'm just going to talk about this one because this one I do use. So let me just jump to definition. So basically we are passing a struct of student type const because I don't want print function to be changing it, and by reference because I want to minimize the memory utilization. I have fixed show point set precision because I want to print GPA to 2 decimal points only. And as you can see, here I've done the member selection, accessing the first name, accessing the last name, and then ID, accessing the ID, accessing the age on last birthday, so many years, and accessing the GPA. So it's actually pretty simple. I'm outputting, doing the member selection using the dot operator for this struct S, and then printing that. So print function is pretty straightforward. And we're going to be using that when we actually find the element. So next thing is my linear search. I want to show you how it changed. So remember it had two extra elements, a flag, two extra arguments, flag and found at by reference. This has no value set by the main function, value will be set here. And we have the student array, struct array, and the key. So that's how our linear function is. So this function will be returning true or false. True if this key is found, whatever I'm looking for in the key is found, and wherever that is found, that index will be returned by reference. But if not found, if this key is not found, then I'm going to be returning -1 by reference for this, found at -1, and I'm going to be returning the false. So what I do is I just assume that I didn't find it. So I set found to false and found at to -1. So if it's not found, this function will return a false, and found at already set to -1. Understand -1 cannot be a subscript or index of an array. Array index starts with 0, can only be 0 or positive, cannot be -1. So that'll tell us that, hey, it's not there. Okay. So what does this flag do? Flag has values, maybe 1, 2, 3, 4, 5. And we kind of decide that if flag is 1, when function call is made, we want to search based on ID. So we do the same thing as we did in the previous linear search function. I go from site index 0 and found was set to false, not found will be true. And the second condition to be tested is I is less than len. Len is the logical length of the array. Okay. So since I was 0, if logical length is more than 0, this will be true. And found was set to false. Negation of false is true. So both conditions are true. I'm going to enter the loop. But now I have flag 1 that tells me that, hey, if flag passed here is 1, then match only the ID field. And I do that very nicely. I take the ARRI I0 dot ID and I see whether it's equals key dot ID. So key is struct, I look at this ID field of that. And if there is a match, then I set the found to true and found at to value I, except I have to cast it to int type because I chose size t here, and I chose size t because index of array cannot be negative. If you don't do this casting, compiler will nag you for that. So I don't want compiler nagging me. So I just cast the size t to int type, and that's perfectly okay. So how does this work? So let's just take this code only, and I'm not sure if I can paste that in my Word document. I will try. Okay, I don't think I can do it, but let's just do it temporarily like this, and I'll delete it later. Okay, so where's my format? Come on, give me a format. Okay, it can't do that. Let's try it one more time. Maybe this was too ambitious. Yeah, format right here. Okay, so we just need to focus right here. ARRI is STARR. So let's say I'm looking for my key struct has ID of 4, 4, 4, 4. So in the first loop iteration, I'll be looking at this one, and then ARI 0.id is this. So there's no match. So I'll move on. Then in the second loop iteration, ARR 1.id is this, and this is 4, 4, 4, 4. There's no match. So this condition is false. Nothing happens here. I move to the next one, and then in the third loop iteration, when I is 2, ARR 2.id is 2, 2, 2, 2, but key ID is 4, 4, 4. There is no match. So this condition is false. Nothing happens inside the if statement. And then I go to the index of 3. ARR 3.id is Cindy Gomez 4, 4, 4, 4. And key.id is also 4, 4, 4, 4. So there is a match now. I set the found to true, and I set the index to 3. So let me just take off this. So that means I found it. Okay. So that's how this code actually works. It's very important that you understand this. So rewind the video, go back and watch it a few times so that you're totally clear how we came about searching this, how we set the found to true, and how we set the found at. Okay. Now if we don't find it, let's go back. Then the key.id will not match any of these fields, and I will complete my array iteration. This will never execute. That means found will remain false, and found at will remain -1. Okay. Now there are other blocks. I'll talk about them in a minute. But once my loop ends, which ends right here, I return the found, and found at is updated if this condition is ever true, and the new value found at is returned by the reference. Okay, so now let's say I wanted to search based on last name. Then I can just match the last name. And I want you to go through step by step, assuming a last name, and walk through this picture just the way I did for ID. So same thing, as soon as I see a match between a struct element in the array, last name, and okay, I'm doing something funny, and last name is stored in the key. If I see a match, then I found it and I set the index I is equal to the found at. And same thing I can do with the age. I didn't do the GPA. Usually people don't search whose GPA is 3.9. There could be millions of those. So didn't do that. And there's an else block, that invalid search basis. That is if they don't pass flag value 1, 2, 3. You need to tell user that there is an invalid search basis, and then we continue our loop. Continue means go to the top of the loop. Okay guys, so that's the only time I can spend on linear search function. Please read the code. You'll get a copy of this code. Read the document, Word document I was just working on. You'll get that. And of course you'll have the video. So make sure you understand that. So now we're going to use this search function, and I'm only going to do one test, search based on ID. There are a couple of other tests like search based on last name and age. You will have to do that yourself. So let's go to the main function now and see how that works. So I do a flag control loop. I set boolean done to false. Since I set to false, not done will be true. And then I have those 4 menu items. Search based on ID, flag will be 1 here. Search based on last name, this is case sensitive. And search based on age. So let's take this one. This is the only one I'm going to show you in the main function. And other two you have to do yourself. So I take the exit choice first, and I say if choice equal to 4, done is true. If done is true, then not true is false, and I'll exit the loop basically. So if they type 4, then you'll exit the loop. But when this menu shows up, if they type 1, then choice will store 1, and then choice equals 1 is true here, so this block will execute. This block is important you understand that. So here I have a variable called inID, ID inputted by the user. I tell them to enter this to inID to be searched, and I store that in inID. Here's the important part, and this is something students fail to understand. My key, if you look at the linear search function, is not ID, it is actually student. Take a look. My key is student type, it's not ID, or it's not last name. So that's a very important thing to understand. That means I have to construct a key that has same ID that user inputted. So what should I input into other field? Well, you can leave other field empty because search function is only going to look for this. So what I do is I put 0 length string for the first name, last name. This one, whatever user inputs, 0 for the age and 0.0 for the GPA. Now you can fill out other values, but that doesn't make any sense because we are when I call the linear search function with flag 1, you saw the code with flag 1 right here, right here, flag 1. It only compares the ID. It doesn't compare other field. So it's a good idea to put something in there. You cannot, when you do this initialization, you cannot leave this blank or undefined. So you have to put something. So I put 0 length string, 0 length string. ID entered by the user, 0 for the age, 0.0 for the GPA. Okay. And when you do choice 2 yourself or choice 3, in that case you'll take user input for the last name, first name blank, last name 0, 0, and 0.0. So that's how you'll build this twin key. Notice that we only populate the field that is being searched. Others we put the initializing values. And this is something you'll need to use in lab 10. It's very important you understand that. And this is where students get confused sometimes. Okay, found at is something that will be populated to either -1 or index 0 to the largest field value in the array. So function was returning found, and don't get confused between found and found at. Found at is the index, found is the boolean. This is boolean and this is actually int. So don't put found at here. Boolean is different from int, completely different. And then I pass it the uh, array itself. The key that I just built, flag one means search based on ID. Found at will be the index where this key is found, and this should be max. Rather than 5, I'll put max here because I did fill the whole array, and that's how it works. So let's just run it, and I'll just gonna do. I mean, take a look at here. I have ID like 999 1 2 3 4. 4 digits of 2, 4 digits of 4, 4 digits of 1. So if I type any of those, I should find it. If I type like say -1, I won't find it. So let's just do some tests and then come back to this. Okay. All right. So search based on ID, I'll say 1. So if I search, let's say we have been talking about Cindy Gomez all through. 4, 4, 4, 4. Student is found. Full details are below. Cindy Gomez, ID 444, age on last birthday 30 years, GPA 3.7. Okay, so how did that happen? Let's look at the rest of the code. In that, so found will be set to true. Then I have this if statement here. If found, then I say I found that ID and full details are below. And then I just call the print function. And index found at was populated where Cindy Gomez was found, and then just I passed this print function, that particular array element, and that gets printed. Okay, so you saw that my program printed all the same detail that I have for Cindy Gomez right here, and all those details were printed here. All right, okay, well, let's do the next test. I want to find someone which is actually not there. I'll say 1 again, and I know -1 is not the ID, so I say -1, and it says student with ID -1 not found. And the reason, because this time it's gonna execute, found will be false, so that else block will execute, and then it'll say student with ID -1 not found. Okay, so you can do as many searches as you like, unless you type 4, which will exit. And of course you can do search based on last name, case sensitive, and age. But for that, one exercise you have to do is you have to complete this code yourself and this code yourself and understand how those work and match that your analysis with this picture here. Okay, you'll get a copy of this document as well as copy of this code. All right, guys, so that's pretty much it, what I'm going to say about linear search of an array of struct. And you can use the flag and search the array with many bases. I've shown you for one case where flag was 1, and when that happens, then this piece of code gets executed, and you need to do the other 2 in the main function. Flag equal to true, search based on last name. Flag equal to 3, search based on age by yourself. Fill out code here, fill out code here, and complete it and run it. That's the only way you're going to own this piece of code and this program and this technology. To own a technology, you have to practice it. Practice, practice, practice. Otherwise, you cannot own a technology. Technology is something that requires tremendous amount of ardent practice, and then you learn it. It's just like you can't become an athlete without doing push-ups and exercises. You cannot become an engineer without practicing the technology. You cannot become a musician without practicing the instrument that you're playing. You cannot become a writer without writing a lot. Same thing with technology. You can't become a computer scientist, technologist, or engineer without practicing the technology. So you have to practice and practice and practice. So this is it, and this is the end of video number 2. I will do a next video on binary search, and then 2 more on sorting, and then we'll be done with chapter 2. Thank you so much.